Hello everybody and welcome back to Alaris Labs YouTube channel. By developing this system, we are trying to satisfy all requirements which are needed to make your business more flexible and comfortable. That is why in one of the latest versions the new functionality error code translation was added, and in this video we will describe it in as many details as possible. Hopefully you will get all the required information by watching this video, and it will help you to configure the translation without difficulty. Generally, in the SMS exchange there are a lot of reasons why the message could be rejected, as it passes several steps and phases before it will be delivered. To understand the reason behind message failure, there are several error codes and statuses which can help you and your partners to determine it. So it means that error codes and statuses can be used as a tool to show your partners the reason why the message was rejected and the way how the issue can be solved. Let's firstly check why the error codes and the statuses can be found depending on the protocol. As you may know, by getting the submit SM packet, in the SMTP protocol the SMS switch needs to answer with the submit response packet. So this is the first phase where you can find the error and the status codes. Let's check the field where you can find these error codes. We will open the submit response packet and you can notice the field SMTP common status. Here you can see the value, which description can be found in the official SMTP 3.4 document on the page 112. This document can be found under this video. This exact code means no error. The full list of the supported codes will be discussed later in this video. The second field where you can find the error codes and the statuses can be found in the delivery packet. But there are two variants where they could be found. The first and the most popular way to return the status and the code which is used by the SMS sender is to use the field message. Let's open the delivery packet and check this field. As you can see, here are all technical details including status and error. The full list of all possible statuses which can be returned by the SMS sender can be found in the same document on the page 130. As it is just the recommendation, your partners can provide you with different statuses. But in our example the status is delivered and the code is equal to 0. The other fields which are not always present in the packet, but where you can find the same information are the message state and received message ID. They both can be found as optional parameters in the same delivery packet. As you can see, you are able to notice here the same data. So that are all fields which can contain the error and status code in the SMTP protocol. As for the HTTP protocol, generally the logic is the same, but the format is a little different. It means that by requesting the message sending using the HTTP link, the switch will also return the error code with the status, but the form will be different. So by receiving the message by the link, the switch will return the following answer. Here, 200 OK is the code. The full list of the possible codes and statuses which could be returned by submitting the message will be discussed later. By requesting the query and the status of the message, the switch will also return the answer, and here's the response sample. The full list of the statuses will be also later described. So, we have described all fields in which the error codes and statuses can be found. Now let's check the possible translations which can be configured in our system. Firstly, we need to pay your attention to the fact that there is a special table in the system which contains the system error codes statuses. It means that to translate the vendor code to the client you need first to fill this table with the system codes. Additionally, you need to decide which codes needs to be returned to a client, as sometimes it is needed to provide them with the exact list. That is why you need firstly prepare it. For illustrative purpose, let's imagine the standard client and vendor configuration and the mentioned table in the Alaris system. The translation can be one of the following types. From the vendor side, it is possible to translate SMTP vendor delivery error code to the system code, SMTP vendor delivery status to the system status, by receiving the delivery packet from the vendor, and HTTP vendor delivery error code to the system code, HTTP vendor delivery status to the system status, by querying the status from the vendor. As for the client, in addition to delivery translation, it is possible to translate system code to the client HTTP and submit response code. It means that you control the code which will be sent to the client by receiving HTTP or SMTP submit request. For example, you can translate the standard code no routes to 69 submit message has failed. Additionally, you can change the code and the status of the delivery of the SMTP protocol. System delivery record to the client SMTP error code. System delivery status to the SMTP client status. And return the different code by querying the status by the client in HTTP protocol. System delivery error code to the client HTTP error code. System delivery status to the HTTP client status. The last translation which was added is routing response code to EDR message status text. Now the system always returns no routes and put it in the EDRs, but you can change the status depending on the reason, blocked by credit or message limit exceeded and so on. As you can see, generally you are able to translate the vendor code and status to the system code, and system code and status to the client code and status. Let's check and investigate the interface of the error code translation. You can find the interface in Start, SMS, Translation Rules. Here we added two separate tabs, Error and Status Codes and Code List. The first tab was added to create translation rules and it will be considered later. Let's firstly check the second tab where you can find the table which was already mentioned before. On the top grid there is a table of the submit response statuses. These codes and statuses can be used as a target translation in answering the submit packet received from the client. On the right side you are able to add and edit these codes as usual. Let's add for the demonstrative purpose our own code. As a type we use SMTP, status code, description and error code. We'll make use of this later. System delivery error code list can be managed through the same tab as well. Lower grid shows already present values. The same with the top grid, you can add and edit these codes using right side of this grid. Now let's move to the interface error and status codes. On the left side you can see the list of the rules already created before. For your convenience you are able to filter them by the following parameters. If it is needed, you can also hide some columns by using the option on the navigation toolbar. Let's create a new translation rule and check all fields. The first option which needs to be chosen is the direction. As it was discussed before, there are two general options. You are able to translate the code and status from the vendor side to the system and from the system to the client. So in this field you need firstly to determine this. For our example, let's firstly use the client side. As you can see, we have discussed several possible translations for the client and all of them can be found in this list. We will use system code to the client submit response. This checkbox and these fields are used to filter the right carrier or several of them for which the rule will be applied. But we will use the option all channels. It means that this rule will translate the code for every client. Now let's check the field source code. As you can see here in the list of all available statuses which can be translated for the client. For example, we will choose the status no routes and as a resulting code the code which was added before in the tab code list. It means that every time when the system receives a submit packet and no routes are found, the client will receive the submit response when in the field SMTP common status this code will be present. We now propose to move on to the second example. Let's imagine that our vendor provides us with the status finished, but we need to translate it to the status OK for our client. But in the system the status should be delivered. To satisfy this requirement we need to create a new rule and firstly choose the vendor side. As a type, let's select the option SMTP vendor delivery status to the system status. It means that we will translate firstly the status finished to the system one delivered. After we select the right channel, we will specify the field source code as finished and as a resulting code, we'll choose one from the available list. After creating this rule, all deliveries with the status finished will be converted to the status delivered and it will be present in the EDRs. As you may have guessed, as the next step we need to add a separate rule which will convert this internal status delivered to the status OK. Let's choose the option client, option system delivery status to SMTP client status, source code delivered and resulting code OK. So the configuration is complete. Now the system will satisfy the requirements and by receiving the status finished from the selected vendor will convert it to the status OK, which it will be sent to the client. Let's consider the third example. You have client A and client B with the traffic which you pass to the vendor C. Client A and vendor C use SMTP protocol, while client B HTTP. two clients sent two messages which you have passed to the vendor, but they were rejected with the error code 255. You need the system send the delivery to the client A with the error code 100 to the vendor B with the error code 15. Firstly, after receiving the mentioned delivery from the vendor C, we need the system translate the code to the system 1. Let's create a rule for the system translation. Direction: vendor. Translation type: SMPP vendor delivery error code to system code. Carrier: source code, resulting code. This rule will translate the vendor code 255 to the system 255 YouTube test. Now we need to create two different rules. The first rule will have the following configuration: direction, client, translation type, system delivery error code to client SMPP error code. Carrier, client A, source code 255, resulting code 100. After submitting this rule, the client will receive the code 100 in case the system code is 255. The second rule will satisfy requirements for the client B. Let's configure a new rule: direction, client, translation type, system delivery error code to client HTTP error code. Carrier, client B, source code 255, resulting code 15. So, as you probably guessed, the configuration is finished. Now, after we receive the code 255 from the vendor B, the client A will receive the code 100, but the client B 15. You can use other types of translation to satisfy your different business scenarios. Well, these are all technical details which we plan to describe in this video. Hopefully it was useful for you. In case you have any questions which were not answered here, you can always contact our support team. If you have any suggestions regarding the channel development, we'll be happy to get them also by the following email. So see you in the next lesson.